Alright, so in this video we're going to talk about something called scientific notation, but before we really get into that, I actually wanted to talk to you about the sun. Okay, the sun, our sun, has a mass of about, wait, let's see, let me look it up again before I forget. Okay, so the sun's mass is something like this. So 199, and then a lot of zeros. There you go. So this is the sun's mass measured in kilograms. Okay. And so clearly the sun is very massive, and this is a number. And let's say I wanted to tell you about this number, but I don't even know what this number is called. I don't know how to tell you what it is because I don't even know what to call it. If it was like 6 zeros, I could say it's something million. If it was 9 zeros, I could say something billion. Or then beyond that, you could do trillion. But to be honest, I don't even know beyond that. Let's see. This is like 28 zeros, and then the 2 9s. And the one, let me look it up. Okay, so here I found this table, and so a nonillion is when you have 30 zeros, an octillion is when you have 27 zeros. So this is going to be something like 1 nonillion 900 sorry, subliminal messaging there. 190 what did I say? Quintillion? And those are kilograms. So that would be the mass of the sun. Okay, what do you think? Is that a good way to talk about the mass of the sun? Can you think of it maybe a better way? So generally, what you would do if you want to write a really big number like this is write it in scientific notation, okay? Because think about this for a second. There's 28 zeros here, okay? And those 28 zeros each play a pretty significant role in talking about the magnitude of the mass of the sun. Because if you chopped off, or if you forgot about just one of these zeros, that would mean the sun's mass is what, a tenth of what it really is. And if the sun's mass was a tenth of what it really is, then life as we know it would not exist. It's probably, I don't even know if the Earth would exist, to be honest. And if it was an extra zero there, probably the Earth wouldn't exist either. Our solar system would look totally different. Okay? And so when we're talking about numbers, the amount of zeros here are really important, and the exact number of them also really important. You don't want to shift around the magnitudes at all. So this is 1.99 times 10 to the 30th, and probably you've seen scientific notation before. Basically the way that you do it is you figure out what you would have to multiply this by to make it into this. And so the way I like to do this, I kind of like to start here and count all the decimal places, okay? And then going back the other way, you would just take the decimal place. If you want to go from here to there, you take that decimal place and move it 30 times, okay? And so that's scientific notation. And really what I want to talk about, though, is how scientific notation can actually simplify our lives a lot more. In addition to being able to shorten numbers, it can make doing operations and making estimates even easier, okay? So here's the rules for scientific notation. My assumption is that you're already familiar with these rules, but if you're not, then this is an opportunity to learn them. So if the exponent is positive, that means it's a number greater than 1. And if the exponent is negative, that means it's a number smaller than 1. So 1.3 times 10 to the second, that would be like this times 100, okay, or 130, okay? 1.3 times 10 to the negative second would be like this divided by 100, or 0.013, okay? And so real quick, before we continue, go ahead and write number 2,340 in scientific notation. once you've done that, it should be something like 2.34 times 10 to the third. Okay? Now before we continue, something that I want you to think about is whether or not we should include this 0 when we write it. Okay, you saw the video on significant figures, and whether or not you write that 0 at the end is an indication of whether or not that 0 is a significant figure. Okay, I'm going to tell you right now that we're not going to worry about that in here, but let's say you're using a textbook and they have written the number 2,340 in scientific notation like this. What they're doing is they're communicating to you that this is not a significant figure. Again, we don't need to worry about that, but just in case you see a number written in scientific notation you're expecting it, this is so you don't get confused as to why. Okay. In addition, we want to write this number now in standard form. Okay, so go ahead and write this number out as a full number, not abbreviated in scientific notation. And hopefully you got something like 3, 7. We're going to move that 5 spaces, so that would be 1, 2, 3, 4 zeros in front of it. So 0.000037. Okay, and so there we have some scientific notation. Real quick, we'll talk about just some operations with scientific notation. Let's say that we wanted to multiply two numbers in scientific notation. Let's say 2.3 times 10 to the fourth, and we're going to multiply that by, say, 1.6 times 10 to, we'll say, the negative third. Okay, so if we want to multiply these, all right, we can do this actually really simply. We get out our calculator, we'll multiply 2.3 times 1.6, okay, and we'll get the 3.68. And then to simplify these exponents, all we have to do is combine them, like using addition. So 4 plus negative 3 is 1, so times 10 to the first. Okay, and that's all you have to do. So you can see this is a way where it can, if you have numbers in scientific notation, we can take some shortcuts because we don't have to type this full number into our calculators. And on that same note, let's say that we're doing some math with some really big numbers. So let's say we're going to find the number of Earths it would take to make up the mass of the sun. So the sun's mass was 1.99 times 10 to the 30th kilograms. Well, if we want to divide that by the mass of the Earth, okay, that's going to be about 5.98 times 10 to the 24th. Okay, and instead of typing this into your calculator, let's just estimate. Well, when you divide exponents, that means that you subtract them. So 30 minus 24 is going to give you 6. And then if we divide, this is about 2. 2 divided by 6, about 1/3. So we'll say maybe like 0.33 times 10 to the 6 Earths in the sun, or Earth's mass in the sun. And then we could shift this, right, to adjust it to be in scientific notation. So that would be actually 3.3. We move over 1, so we'll take 1 off of there, times 10 to the 5th. And so the sun's mass is equivalent to 3.3 times 10 to the 5th of the Earth's mass, okay? And so that's like, that'd probably be at like 330,000 times more massive than the Earth, okay? So this is just some examples of how we can do some quick math with scientific notation by combining the exponents. And we just made an estimate here. You could even punch this on your calculator, see how close we got. But it's probably pretty close because these numbers are pretty closely rounded up to. So anyway, just a little bit on scientific notation. I hope it was helpful and not too much review. And if you do have questions, I'd be happy to answer them in class. Okay?